with this input source you want to add, assuming some sine wave. Sine wave may have different entries. Those entries are DC offset voltage. We understand what is DC offset voltage, right? We understand what is amplitude. Amplitude means the sine wave. So if there is a sine wave, this DC value is known as DC voltage or offset. Sometimes people call it common mode voltage also. And this one is amplitude. This one is period, or 1 by period will give you frequency. So you can define it whichever the way you like, right? So let's assume that I don't want to do the transient analysis right now. Whatever I've shown you was transient analysis. If you want to do something with respect to time, it's known as transient. But I'm not interested in transient. If I'm interested in something called AC analysis, AC analysis is the one where frequency will be at the x-axis, or the frequency will be varying. I want to see the frequency response in AC analysis. It might be magnitude or it might be phase, which is known as commonly Bode plot. If you wish to do this, then generally we are interested in transfer function, right? So there is one trick which all the engineers are doing it. If I want to find out transfer function, which is V out divided by V in for all the frequency component, if I make V in equal to 1 volt, then V out is equal to transfer function, right? But when we are doing this, remember, when V in equal to 1 volt, if you are writing that at AC magnitude equal to 1, if you are doing this in the simulator, so here in the simulator you can see there is something called AC magnitude. If you are writing AC magnitude equal to 1, that means that for all the frequencies, even from minus infinity to plus infinity, it's equal to 1. This is the meaning of AC magnitude equal to 1. For all the frequency, it's 1. And afterwards, if it is passing through some circuit, your output might be low pass, high pass, band pass, or something will be there. So you can analyze its UGBW and other things. So if I'm interested in finding out the AC response, then what I can do, I can give here AC magnitude equal to 1, AC phase equal to 0, because that is the input side, and then done. This was the starting point. Here a few more things which are left, which are giving the values of resistance and capacitance. So whichever value you want to add, you can right click on that particular component, and you have to give the value of plain capacitor or the plain resistor. Otherwise there are many other entries are available. So those entries are series resistance, series inductance, parallel resistance, parallel capacitance. So what do you think, what could be like the reason for adding these things also? These are the parasitics, right? In reality, resistance is not pure resistance, or capacitor is not pure capacitor, or inductor is not pure inductor. You'll find some more things. And if you want to make something very specific to some manufacturer, you just add that manufacturer and you find out these values. These values will be available in the data sheet of particular resistor or capacitor. You need to find it out on Google. It's available very easily. Like with the one search, the first search will be these values, and you have to add here to make everything in the like in the real scenario. Like capacitor, if I am giving 1 micro, but in reality it will not be 1 micro. By the way, micro will be given in with the symbol called U. U is equal to micro, and there is no need to add any unit like Farad, Henry, or ohm or anything. Like here we added just 15, here we added minus 15. So there is no need to add units. Remember that. Do not add units anywhere. So here you can see it's 1 micro. Even again for this resistance, I can keep somewhere like, let's say, 100 kilo. And capacitor, again I am keeping something like 10 micro. So it's 10 microfarad, right? So after this, what do you think? What should I do? How to run the simulation? So here there is something run symbol is there, but the only problem is which analysis has to be run. This is not known to my simulator. Means transient AC. I need to tell him till what point it has to be run. Like if I want to run transient, and if I want to see the signal till 1 microsecond, then I have to tell him that run the simulation till particular point. So in that case, you need to right click it, go to draft. Yeah, there also you can do that. So there are many ways, but first thing is you need to define this particular analysis. It can be okay. One more time, you have to go to draft in Spice directive. So if you are expert of writing netlist, if you remember, you need to understand netlist. If you are doing this, this is just graphical way, which is not at all useful. In reality, this is being made for those people who are the learners. Means they are doing it first time. If some advanced people are there, they are going to write down the netlist. I'm going to tell you how to write down netlist, or will generate it automatically first, and then I'll teach you. But if you don't know how to write the netlist for giving the analysis type, you need to write here help me in edit, and you have to go to analysis command. So now you can, like, this LT Spice is going to write the command for you. So which analysis you want to do, that is important thing. If you are interested in transient, which is with respect to time, AC analysis with respect to frequency, DC sweep means some of the component DC is like with respect to DC, right, with some values. Noise